We're going to simplify square roots and higher order roots of quotients. So assuming all variables are positive, we can use the rule that the nth root of a over b, which is a quotient, equals the nth root of a over the nth root of b. In other words, it's the nth root of the numerator over the nth root of the denominator. So we're going to do these 5 problems. These are fairly basic problems. We won't have too much trouble simplifying them. All right, so let's start with number 1. We had the fourth root of 16 81st, so that's the same thing as the fourth root of the numerator over the fourth root of the denominator. And the fourth root of 16 is 2, and the fourth root of 81 is 3, so that's our answer. For the second problem, we're going to do this again, except we have a cube root. So we're going to do the cube root of the numerator. So that's the cube root of 27, y to the 12th, over the cube root of 64, x to the 21st. All right. So 27 is a perfect cube. The cube root of 27 is 3. And the cube root of y to the 12th, remember, you could just divide 3 into 12. If that goes in evenly, that'll be your new exponent. So that'll be y to the 4th. So I have 3y to the 4th in the numerator. Now in the denominator, 64 is also a perfect cube. So the cube root of 64 is 4. And the cube root of x to the 21st, again, that's just 21 divided by 3. It goes in evenly, so that all of that comes out x to the 7th. And there's our second one. All right, going on to the third problem here. We have a fifth root. Same thing, we're going to do the fifth root of the numerator, so the fifth root of m to the 25th over the fifth root of 32 n to the 5th. All right, so the fifth root of m to the 25th, since 5 goes into 25 evenly, we just divide to get our new exponent, m to the 5th. And the fifth root of 32, well, that is 2. It's a whole number. And the fifth root of n to the 5th is simply n. So here's our third problem. Let's go on to the fourth one. We have a square root. So we're going to have the square root of the numerator. Now, notice that I have 20, and that is not a perfect square. So I'm going to rewrite that as 4 times 5, as the perfect square. 4 times 5 times that x to the 10th. And in the denominator, 49 is a perfect square, so I'm going to write square root of 49. So out of the numerator, the square root of 4 I could take out. That'll be a 2. And the square root of x to the 10th will be x to the 5th, because you divide 2 into 10. But I still have this 5 underneath the square root, so that's still there. And in the denominator, square root of 49 is 7. So that's as far as we can go with this one. Okay, the last one. Now, notice I have 2x squared times the square root of a quotient. So that 2x squared is really in the numerator. So I'm going to write it that way. 2x squared over 1. And I have to do the square root of x to the 8th over the square root of x to the, square root of 16. All right, so what does this give me in the numerator? Well, I have the 2x squared. And the square root of x to the 8th, again, 2 into 8 is 4, so the new exponent is x to the 4th. And I have 1 times square root of 16, so I'm going to write that 1 times 4. So now I have to use my laws of exponents. X squared times x to the 4th, you add exponent, so I have 2x to the 6th, and 1 times 4 is 4. And there are 5 examples. Hope you learned something. Try them on your own now.